let this part is infinity, this part is also taken to infinity. It is entirely carrying current I, continuous current I. So what will be the magnetic field at this 0, 0, 0? What will be the magnetic field provided if I if I suppose saying this separation is A, this separation is also A, right? And let this part is 2A. This part is also 2A. Got this information? Is it clear now? So AC is lying on XZ plane, CD is on YZ, right? DE, that is also on YZ, EF is YZ. So CD, DE, EF, these three parts are lying on YZ, and AC and FG are lying on XZ. So find magnetic field at O. So all are just straight sections only, straight wires. Yes, what will be the magnetic field due to section 1? First tell me, magnetic field due to section 1. What you'll write down about its result? How far it is away from, what is the perpendicular distance of this wire from the required point? This line is parallel to x-axis, so this distance is suggested A, means this much is A. Yes or no? Right, so being it is semi-infinite, one end is closest, right? So I can write down it is mu naught I by 4 pi A. Direction of this will be perpendicular to the plane inward, that is inward means downward, basically it will be along minus y, because this is lying on xz plane. So into the plane means with respect to yz plane, into means towards negative y-axis, so that's why minus j, right? Similarly, what do you think about the magnetic field due to the last part, that is if this is 1, let this is section 2, this is 3, this part is 4, and last part means 5. So what will be the magnetic field due to section 5? That too is semi-infinitely long wire, that too is lying on xz, right, equal, but direction wise will it be along positive y or negative y? Are you sure? Yeah, because always you need to confirm. See, this point is here, one part is this, another part is this. So though, I mean like these two parts are not connected on the same plane, like, okay, this is the negative z-axis, this is positive z-axis, and this part is x-axis. But ultimately, with respect to point this, right, as because this conductor is not passing through the O, this distance is A, this distance is also A. So can I say that about this point, it has got a order of clockwise on xz plane? Yes or no? So whenever you will see that the sense of current is creating one order, right? If clockwise, then whatever be the plane, magnetic field will be perpendicularly into the plane, right? So that's why with respect to xz plane, out of the plane is positive y, inward of the plane is negative y. So that's why for this one also it will be same. So I can say magnetic field due to the section 5 will also be same, right? Are you getting me or not? So whatever will be the result for section 1, the same result will be applicable for section 5 at the point 2. Now we have done 2 out of 5 wires, okay? Now, so far as CD, DE and EF, is it again following one continuity, one order about the point O? Again, if you see that this existing plane is which plane? Tell me. This 3 section appearing on which plane? Correct, YZ. So about O, this YZ plane, it is clockwise. So again, clockwise means due to this entire 3 portion, magnetic field will be going this way. That means B of 2 plus B of 3 plus B of 4, all of them, they may be different in values, but direction wise they will all same towards the negative x-axis, correct. Now for the CD portion, CD is a finitely long wire. CD is a finitely long wire and required point O is appearing like this, yes or no? So for finitely long wire, do we apply the formula this way? Do we apply the formula this way, taking one is alpha, another one is beta? So now, if suppose, if these are the two finite ends, right, and out of these two finite ends, if one end is shifted closest, if one end is shifted closest to this, so alpha will tends to 0 degree, yes or no? So only one angle beta will be visible, alpha is 0 here, right? The shortest distance is A. For finitely long wire, magnetic field value, magnetic field due to section 2, right? This can I write down, it is mu naught I by 4 pi into shortest distance. Can it be written sine of alpha, sine of 0 plus another one is sine of something. What will be that something? This is being A, this is given 2A. Yes or no? Check the geometry. Is it given 2A? Is this A? So when I'll join, this is the beta for me, yes or no? So for beta, I know base is not known, perpendicular is known. So what will be this hypotenuse length? Under root of square of this plus square of this? Pardon? Root? No, root 5a. Yeah, root 5a. So for me, now sine beta will be 2a by root 5a. Isn't it or not? So sine beta, so numerical value of sine beta, I should write down how much? Numerator sine beta should be written how much? Tell me. Will it be 2 by root 5? So this is the magnetic field due to section 2 and it is direction wise minus I cap, right? Fine. The portion just appearing opposite to it, the portion opposite to CD, the portion opposite to CD, that is I'm talking about EF. So can I show the EF as this one? Is this the EF? So current is this way, right, in EF. Again the same geometry will appear for the portion EF, right? So magnetic field of this and the magnetic field due to section 4, will it be same? Same in value, and as I said that it is continuity, so going inward, that is minus I. Now this is about the section 3. Section 3 is this one. This is the section 3. Right. Section 3 is altogether itself is of length 2a. Shortest distance this time we will use 2a. So this is being 2a, this part is a, right? So this time this 2 will be like alpha dash, beta dash for the section 3. Both are equal. Yes or no? With respect to this point, are you getting me or not? With respect to this point, this line joining, these two ends, will it be equal in angle? I'm saying alpha dash, beta dash, right? So this alpha dash and beta dash will again be same. This is A, this is 2A. So for the magnetic field due to section 3, magnetic field due to section 3 will be this time mu naught I by 4 pi into shortest distance will be 2A. That into sine alpha dash plus sine beta dash. Are you getting me or not? Both alpha dash and beta dash are equal. So can I write down it is something mu naught I by 8 pi A. Can it be written twice into sine alpha dash? For a sine alpha dash, this time this is the perpendicular, this is the hypotenuse, yes or no? So can it be written A by root 5 of A? So total magnetic field will be now, so therefore the net magnetic field at O, that will be sum of all this. So I can write down, what did I say, B2, B3 and B5 will be all same in direction. So in fact B2 and B4, 2, 3, 4 are same in direction. So B2 and B4 are same. So I can write down, it is twice of the value of B2 and B4. So that should be written 2 mu naught I, right? 2 mu naught I by 4 into root 5 pi A plus this one is coming 2 mu naught I by 8 into root 5 pi A. This is the total magnetic field due to three parts, three portions, that is 2, 3 and 4 with direction minus I plus 2 out of 5. We got it towards negative j and both of them were mu naught I by 4 pi A. So I can write down it is twice of mu naught I by 4 pi A. The direction was I think minus g, right? So this is the final answer.